In the last century, we've seen innovation in design, technology, and transport. And the element that has helped open up this world of never-ending possibility? Aluminium.
First things first, so let's start with the raw ore, which is called bauxite. This is mined mainly in locations around the equator, and it is in this bauxite that aluminium is found. We cannot emphasize enough that Agfagraphics works only with the finest grade of aluminium to ensure maximum performances on the printing press at all times. Quality control is of the utmost importance at every step of the process. During the refining process, any impurities are dissolved from the raw bauxite. Then everything is washed and filtered, after which we end up with a white powder called alumina oxide. Typically, you need 2 tons of bauxite to produce 1 ton of alumina.
Tahap awal adalah pemurnian bauksit sehingga diperoleh aluminium oksida murni atau alumina. Pertama, bauksit direaksikan dengan NaOH aki dengan reaksi sebagai berikut. Al2O3 solid ditambah NaOH aqueous ditambah 3H2O liquid menghasilkan 2 NaAlOH 4 kali aqueous. Kemudian aluminium diendapkan dengan mengalirkan gas CO2 sehingga terbentuk 2AlOH 3 kali solid ditambah Na2CO3 aqueous ditambah H2O liquid. Kemudian endapan aluminium hidroksida disaring, dikeringkan, dipanaskan dengan reaksi 2AlOH 3 kali menghasilkan reaksi Al2O3 solid ditambah 3H2O gas. Kedua adalah reduksi aluminium oksida melalui elektrolisis, melalui proses yang disebut proses Hall-Héroult. Dalam proses ini, aluminium oksida dilarutkan dalam lelehan kriolit Na3AlF6 dalam bejana baja yang berlapis grafit yang sekaligus berfungsi sebagai katode. Dengan cara ini, elektrolisis dapat dilangsungkan pada suhu 950 derajat Celcius dan digunakan batang grafit sebagai anode. Di sini kriolit berfungsi untuk menurunkan titik leleh. Dengan reaksi totalnya 3C solid ditambah 4Al3+ ditambah 6O2- menghasilkan 4Al liquid ditambah 3CO2 gas. Sebenarnya, reaksi elektrolisis dari aluminium ini sangat boros energi. Mengapa? Karena berlangsung pada suhu yang sangat tinggi. Bilox aluminium besar plus 3 dan Ar aluminium kecil 27, sehingga 1 mol elektron hanya dapat menghasilkan 9 gram aluminium saja.
The Bayer process removes the alumina by a series of chemical reactions. After filtration, a mixture of pure aluminium oxide and water remains. The mixture is heated to 1200 degrees Celsius, causing all of the water to evaporate, leaving a dry white powder, alumina.
This video explains the extraction of aluminium by electrolysis of alumina. The electrolysis of alumina is carried out in a steel tank. The hanging carbon block acts as anode, and the carbon lining acts as cathode. The electrolyte is a mixture of alumina, Al2O3, cryolite, Na3AlF6, and small amount of fluorspar, CaF2. cryolite lowers the melting point of alumina, and fluorspar increases the electrical conductivity of the electrolyte. When the electricity is passed through the electrolyte, the alumina is ionized into aluminium and oxide ions. Unlike charges attract each other, hence, the positive aluminium ions will attract towards carbon lining cathode, and the negatively charged oxide ions will attract towards carbon anode. At cathode, aluminium will gain electrons and will form aluminium metal. Molten metal will sink to the bottom of the tank, and aluminium is collected.
The molten aluminium, which is siphoned off, is now basically aluminium in its purest form. Being liquid and at 700 degrees Celsius, it can be poured into any shape. In this case, it is tapped into huge ingots of 9 meters long, weighing 30 tons and more. These ingots will then be further shaped, depending on the industry they are intended for.
The extrusion process begins with aluminum log or billet. These logs are 22 feet long and weigh on average 1,200 pounds. Logs are available in 7-inch, 8-inch, and 10-inch diameter, with alloys such as 6063, 60005, 6463, and 6061. The log or billet is fed into an oven, which heats the aluminum up to around 900 degrees Fahrenheit. This brings the billet to a plastic state, where it is malleable under extreme pressures, but not molten. The log exits the oven and is sheared to an extrudable length, usually about 30 inches depending on the shape being extruded. The hot 30-inch billet is fed to the extrusion presses by the extrusion loader. A large ram then pushes the billet into the container and applies as much as 3,000 tons of pressure, which squeezes the aluminum through the steel extrusion die. When the hot aluminum is forced through the extrusion die, the aluminum takes the shape of the profile in the steel die and exits as a long stock length aluminum extrusion.
Rolling section. The preheated ingots are then rolled into the massive hot rolling section to reduce their thickness for further handling in the cold section later on. The 10-ton ingots are rolled to a depth of about 4 millimeters and measure an astonishing 2.4 kilometers long. Finally, the 4 millimeter thick ingots are rolled onto a coil for further handling. Every single coil gets an individual code. The coils are then left to cool down for later transport to the cold rolling section.
buildings are easily constructed, requiring a minimum amount of maintenance and upkeep. Self-insulating against both heat and cold, aluminum sheet provides greater protection for every type of outdoor use, from industrial buildings, large and small, to the most modern residence. Lightweight, strength, and the versatility of aluminum make possible higher payloads in all commercial vehicles, from highway trailers to modern smart-looking delivery trucks. Aluminum adds beauty and flexibility of design to lightweight highway homes and ultra-modern buses. In national defense, as in many other fields, aluminum is everywhere. In the air, on the ground, and on the sea, versatile aluminum serves our fighting men. In today's architecture, aluminum has become synonymous with modern design, not only in new buildings, but to facelift dingy old exteriors and transform them into colorful new fronts in tune with the times. The use of aluminum is equally effective inside as well as out. From table lamp to acoustical ceiling, aluminum contributes that decorative modern touch to office and home. Because aluminum reflects up to 95% of all radiant heat and effectively stops moisture, it finds extensive use in all types of insulation. These same reflective qualities add extra efficiency to aluminum heating and air conditioning ducts. In the field of home appliances, for decorative as well as functional uses, aluminum has no equal. Rust-proof and corrosion-resistant, it helps keep cleaning and maintenance at a minimum. Add the advantages of low cost, lightweight, workability, and multicolored beauty, and it's easy to see why more and more aluminum is being designed into every type of modern appliance.
What turns dreams into reality? What takes us down the street and across the finish line? What inspires us to reach for the stars? Aluminum, the modern metal. Lightweight and strong, aluminum makes cars safer and more fuel efficient, and makes for a sustainable future. Aluminum saves energy, and it's 100% recyclable. In 60 days, a used aluminum can will be back on the shelf. Of course, aluminum is vital in protecting our food, but also our nation. It frames our lives and our tastes. It shelters us and sets us free. It's used in the technologies for the future and in monuments honoring the past. It's more than foil, it's our lives. You're likely never more than 6 feet away from a piece of aluminum. It's probably on you this very moment. A phone, eyeglasses, zipper. An amazing metal that makes every day possible. The sustainable material of choice because it's lightweight, durable, and infinitely recyclable. Aluminum.